So you imagine we sort of describe it as a platform for digital creativity. It's similar to I guess, a serious gaming engine like Unity, but for serious apps. We kind of sit in this space between kind of rapid development tools and native tools, but we do give people native performance on iOS, Android, Windows, and OS X. What I'm going to talk about specifically is Cospacing and some of the experiments we've been doing creating high-value training materials. We're using a phase-based 960 Hertz active tracking system. So you can track props to incredible accuracy in 3D. You can track people, but we consider Cospacing to be the combination of users, props, and the physical sets, all in known room-scale tracking. And it really does change the way you interact, particularly when you're in a VR situation, but certainly in AR as well. I'm just going to quickly cover the three main use cases. The first one is data visualization and narrative. So this particular presentation has been used by WPP, the advertising agency group, at the House of Lords here in the photograph, and also at New York Stock Exchange. There's about 6,000 data points that you can kind of explore, which would be way too intimidating, perhaps in a mobile app or in a traditional app. This kind of lets you zoom in and find the brands you're interested in, find out more about those brands, but wraps it up with a character that you interact with via voice. Role-playing and scenario evaluation. So this is big for police, EMTs, ambulance. This is sort of a high-value training. There are multiple participants and someone running the training session. So it's the way all these people interact together. It's pretty visceral, seeing accidents and having to deal with the consequences, moving those scenarios forward. And the person who's running the situation, in this case the simulation, the trainer, can adjust the simulation as it's running. So they can make it harder, they can change the triggers, they can change the environment, and they can sort of respond to the people and how they're handling everything. And then troubleshooting, repair, and training. This is really, once again, in this concept of you're in a shared environment. So it's not something where you do it in place. This is where you'll be doing it, in the real world, this is where you're doing it in a training situation. So, for example, you might be working out how to triage a wind turbine before you get in a Sikorsky helicopter and fly out to the North Sea and have to do it in person. So this allows you might be a very experienced group of technicians, but it means you can work together, figure out what your toolkit's going to be, what are the problems you might encounter, and kind of go through that whole strategy before you go out there and have to deal with the rain and the sea. We made a whole bunch of interesting discoveries in the process of doing this. So one of the interesting discoveries is that people and the room are all in scale together. So your virtual world and your real world are in exactly the same space. But the scenes you're interacting with, so for example, a command and control scenario, you're sort of in this, this larger-than-life, real-time strategy style posture. People can walk around kind of submerged waist deep in the landscape and point at things. They're still using all the visual landmarks. If you know the Boston area, you're able to utilize all of that, but also be able to utilize the gestures and the fact you're working together to achieve shared goals. One of the big challenges we had with a shared interface environment is you've got to have some place to put the interface where people can walk over and use it. You don't want people to have their own separate HUDs because you're in a shared environment collaborating together. One of the interesting discoveries was that's just a piece of foam, that tablet you can see there on screen, that's being tracked in 3D, and you can present on top of that tablet the 3D interface that you want to interact with. So it makes it very easy for the person who's controlling the simulation to be able to select options and pick things without breaking themselves out of the environment. Body language is a really big deal, particularly interesting in VR. In AR, that's always been there, but in VR, now that you have a full avatar of all the people participating in the simulation, in this case, Richard with the tablet is controlling, he's the trainer, and the trainee just turns the head and it's clear that he's looking for some guidance on what to do next. So that all the kind of things you see in the real world in shared scenarios come into play. Coincident experiences are very surprising for people in VR. So this is an example where you've got the shared tablet with an interface on it. Adam's reaching out, so he obviously wants to be able to interact with the tablet. So Richard holds it out from to press. And when Adam presses on the tablet, he's pressing on it in the real world as well as the virtual world. So Richard feels the tablet move, which is completely logical, but quite a surprising experience, as I say, in VR. One of the things that was unexpected is that voice commands have a lot of challenges. People have to know the voice commands. You have to present them to people somewhere. We've actually found that dialogue triggers are a lot more successful. So if you're doing a police stop and you have to follow essentially a list of phrases that you're required to speak, put your hands on the wheel. You can say, please put your hands on the wheel, or some variation thereof, and it's still going to pick it up and accept it. We're using any one of the major voice recognition engines, and as long as you're passing that data at high speed, you can do some, it's pretty impressive because it's picking up the words as you're speaking them, so we can move the simulation ahead as you reach that threshold. One of the interesting discoveries is materials really do matter, particularly for trying to perceive I guess, depth and detail and things with today's headsets. And having, flat areas of monocolor are very hard to perceive in stereo for the human visual system. So pumping up those materials and having some detail in there really makes a big difference. A number of the presenters have spoken about this. I'm a huge fan of the human visual system. But there's no doubt, I mean, we were originally focused with AR on the through displays, but you have the gamma problem that everyone's been talking about. And there's no doubt, if you look at the right-hand side, the traditional composited AR that you'd see on a phone, now doing that in stereo is completely manageable. You just need slightly higher resolution cameras that are currently available. But it means you really do get to control everything about the final image that's presented. Now, because we have a full 3D scene and we know where all the props are and all the people are, we can manage all of the occlusion. So you can have people walking in front of virtual things or behind virtual things, or behind real things and in front of virtual things. And in the case of the additive rendering, that looks really weird because you're walking behind, you're occluding something that's bright. It just doesn't look sensible. Whereas in the composited world, we can control everything, including adding shadows. So we can make really good looking synthetic AR scenes. I should say, this is a very unexpected accident. So proprioception is a big deal. I mean, it's a thing we have. We can run around. We know how hard. We know we can pick up an egg versus picking up a coffee cup. We've got all these things that our body does that are sort of built in. And one of the interesting aspects here is this was designed to work with a real drum kit. And when we went to make the video, the drum kit had been taken home by one of the staff. So he was drumming in midair, yet he was still crashing through the cymbals and stopping on the tom-toms. And we had to ask him to look where he was drumming so we could capture it on the screen captures, because he was just naturally drumming where his hands wanted to go, and he knew where the drum kit was in space. And it was actually his drum kit, so he even knew where everything was placed. So the mental models we can build once you have good stereo perception and super accurate tracking. So this is sort of a 4 millisecond latency and sort of millimeter accuracy. So it's absolutely amazing how real this feels to people, even when the physical things aren't there, although we always try and make things coincident. In terms of production, there were some good talks this morning about the challenges. We've had a lot of success with Real Illusion. It's a parameterized character builder, so it lets you quickly create your own avatar. That avatar is already rigged, and then we have a full IK system. We have trackers for the shins, the hands, and the head, and that's enough for us to drive these characters pretty successfully using a range of motion. So the avatars you see in real time with PBR lighting are all, pretty impressive characters. You can ramp the level of detail up and down whether you're targeting mobile or WMR. Obviously the motion capture, you get that as part of the deal. Our system allows you to place all your NPCs, your props, and do all your scene editing. And then you can set up all your body and hand and look at cages. So as also mentioned, one of the really interesting things about VR and AR, even without eye tracking, if you've got at least gaze tracking here, is you can tell where people are standing. Are they standing in the right place for this traffic stop? Are they standing in front of the front column of the car? In which case there's a risk the person in the car will draw a weapon. Did they check the number plate? Did they check the wing mirrors? Did they, in the case of entering a building, did they check their six? They check the sides. We have a scripting environment to set up all the different interactions. So you can see here in the center one, if you walk into that cage in front of the front column of the car, then it plays the perp get sitting gun animation. So the people draw their gun in the sitting position when you accidentally trigger that cage by walking too far forward. And then the Imagine editor allows you to build all of those UIs for the people to control the interfaces and to build interfaces that may exist within the simulations as well. And we've got a Cospacing volume at the CRC in Boston, so you'll be able to see any of this live as well.